Okay, part 3 of the review problems for the geometry final. This will be exclusive for geometry honors. Okay, in the diagram below, what is the length of side BC round to the nearest hundredth? So BC is this side length right here. And we're given this angle is 40 degrees. And we see it's a right triangle. So we can label the sides based on the 40-degree angle. The angle that we're given, other than the right angle, is the reference angle. So you go across from that angle, and that side length is going to be your opposite. Across from the right angle is always the hypotenuse. And the remaining side is your adjacent. Now we're going to use SOHCAHTOA. Okay, and the side lengths that we actually have are the opposite and the hypotenuse. So we choose the trig functions based on the sides that we have. So here is the one with opposite and hypotenuse. So that's going to be the sine function. So the formula, the sine of an angle theta, is going to be opposite over hypotenuse. Okay, and rewriting, we have the sine, and the angle theta is 40 degrees. And that equals opposite, which we don't have, so I'll just leave it as question mark. You can call it x if you like. The hypotenuse is just 7. Now at this point you can put this over 1 and cross multiply, or since the question mark is divided by 7, the opposite of dividing by 7 is multiplying by 7. Okay, so I could just do that to both sides. 7 divided by 7 cancels. And the question mark is going to be 7 times sine of 40. Okay, sine of 40 is all one number. So you need the calculator, and make sure your calculator is set to degrees. So 7 times sine of 40, rounding off, I get 4.50. And that's the question mark. So that is the side length, BC. In the diagram below, what is the measure of angle B round to the nearest hundredth? Okay, here's vertex B, so this has to be angle B. And that's what we're looking to find. And that's our reference angle. We see it's a right triangle, so let's label the sides based on the reference angle. You go across from the angle to the side, and that's going to be your opposite. Go across from the right angle, and that's going to be your hypotenuse. So that's 12. And the remaining side is going to be your adjacent. So once again, we're going to use SOHCAHTOA. And you want to look for the sides that are given. We have adjacent and hypotenuse. So you want to use the trig function with A and H. That's this one right here, adjacent and hypotenuse. So we're going to be using the cosine function. That's what the C stands for. So cosine of an angle theta is adjacent divided by hypotenuse. Okay, so the angle theta we don't know. You can keep it as theta or plug in the question mark. Either one is fine. So rewriting, we have cosine of question mark. And that equals adjacent, which is 5. I'm going to leave a little space here and you'll see why. And the hypotenuse is 12. Now, Again, this is all one number right here, but we're looking to isolate the question mark. So we can't divide both sides by cosine. We need to use the inverse function. So what you want to do, applied to this whole thing, instead of cosine, we're going to do inverse cosine. Okay, it looks like cosine to the -1, but that's not an exponent, that's inverse cosine. And you have to do that to both sides. Okay, inverse cosine. On the left-hand side, cosine and inverse cosine cancel. We're left with the question mark. And you need to do this on the calculator. Again, make sure you're set to degrees. And rounding off, I got 65.38 degrees. Given that ABCD is a rhombus, what is the measure of angle BDC? Okay, if we go BDC, that's this angle right here. So we can just call it X for now, X degrees. All right, and this is a rhombus, and a rhombus is basically a type of parallelogram. Okay, so opposite sides are parallel for a rhombus or a parallelogram. So I'm going to mark the top and bottom parallel, and we can also mark the left and right parallel. Now, one thing we know about a rhombus, the diagonals are perpendicular. Okay, so the diagonals make right angles with each other. So all of these angles in here are right angles. Okay, you can mark all four of them or just one or two of them if you like. But this is going to be a right angle right here. Now, when you have parallel lines, you want to look for the Z shape, and that will give you alternate interior angles. So you make a Z with the parallel lines like this, and the angles inside the Z are going to be congruent. So if this angle here inside the Z is 46, this angle right here is also going to be 46. And now it's easy. Okay, we have a triangle on the bottom. This one here is 90, this is 46, and this is X. We have this triangle here, so just subtract the other two angles from 180. The angles inside of a triangle add up to 180. So 180 minus 90 minus 46, that's going to be 44 degrees, and that equals X. In the diagram below, what is the value of the radius r? Okay, we have a right triangle, and this is actually a tangent line, by the way. Since this is the radius r, this line segment here is tangent because it makes a right angle. But anyhow, we have a right triangle here, so we're going to use Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Okay, C is always the hypotenuse across from your right angle, but that's going to be this entire side length. So the length of that side, we're going to have to add 7 plus r. Okay, so that side length is actually 7 plus r. And since it's across from the right angle, the hypotenuse is represented with C. So c squared is going to be 7 plus r squared. Now the other sides, it doesn't matter, a and b. I'll let 13 equal a, and I'll let the radius r equal b. A squared is 13 squared. b squared is r squared. Okay, 13 times 13 is 169 plus r squared. And it might make it easier to distribute on the right if instead of 7 plus r squared, you cross this out and make it 7 plus r times 7 plus r. That's the same as squaring it. Alright, so you can distribute or use FOIL. So we have 7 times 7, that's 49. And we have 7 times r, that's 7r. And we have r times 7, that's 7r. And we have r times r, that's r squared. Now, if you notice on both sides, we have r squared on both sides and nothing else is squared. So we can immediately get rid of that. The opposite of positive r squared is negative r squared. So do that to both sides of the equal sign. And this cancels here, and this cancels here. Alright, bring down your 169. Bring down your equals, the 49. And we have 7r plus 7r. Combining like terms, that's 14r. Alright, we're looking to solve for r, so get the 49 on the other side. Do an opposite of positive 49, that's negative 49. Do that to both sides. And this right here, 169 minus 49, that's 120. Cancels here, and bring down your 14r. Solving for r, the opposite of times 14 is divided by 14. Okay, I'll probably have decimals for the multiple choices, but if you wanted to reduce, this would be divided by 2, that's 60 over 7. But as a decimal, 60 divided by 7 is approximately 8.6. So that is the value for r. So really, 60 over 7 is the exact answer, and 8.6 is the rounded off answer. So it really should be written like this. R is approximately 8.6, but it equals 60 over 7. Anyhow, the choices will probably be decimals. The ratio of the lengths of the bases of a trapezoid is 2 to 3. The length of the mid-segment is 30. What are the lengths of the bases? Okay, the mid-segment is basically the average of the bases. So the mid-segment is going to equal the average, so that's just B1 plus B2 over 2. How do you find the average of two numbers? You just add and divide by 2. Or you can multiply by 1/2 if you like. Anyhow, since the ratio of the bases is 2 to 3, we can multiply each of these by x. Alright, if you had a fraction, 2 over 3, you can multiply the top and the bottom by x. Okay, multiplying by x over x, it's the same as times 1. So I'm allowed to do that. 2 times x is 2x, and 3 times x is 3x. So those are going to be representing the bases. Okay, I'll have the 2x equal b1, and I'll have the 3x equal b2. Alright, multiplying by x doesn't change the ratio, so I still have the same ratio. Alright, anyhow, it said in the problem the mid-segment is 30. So I'm going to plug in 30 for the mid-segment. Alright, in place of mid-segment, that's 30. B1 is going to be 2x, and B2 is going to be 3x, and those are divided by 2. So what's the opposite of dividing by 2? Times 2. So I'm just going to do times 2 on both sides. And over here, 2 divided by 2 cancels. This is a denominator and a numerator. 2 times 30 is 60. 2x plus 3x is 5x. Okay, and now solving, the opposite of times 5 is divided by 5. It cancels here. And x is 60 over 5, which is just 12. Now, we said the base 1 is 2x. So that's going to be 2 times 12, or 24. And we said base 2 is 3x. So we have to take this and plug it in. 3 times 12 equals 36. Alright, so you just take the x and plug it in to get the actual base length for each one. Let the angle theta equal 3 pi over 5 radians. What is the equivalent angle in degrees? Okay, we know that once around the circle is 360 degrees. But in radians, that equals 2 pi. I'll just abbreviate RAD. Now solving for pi, if you divide both sides by 2, 360 divided by 2 is 180, and that equals pi. So 180 degrees is pi radians. Now you can use the fractions to convert, but since we have this equivalency here, we can just use the shortcut and plug in 180 in place of pi. Plug in 180 in place of pi. Okay, that only works when you're going from radians to degrees. Alright, so if we take the 3 pi over 5, that's just going to be 3 times 180 over 5. Alright, and I don't want to make a mistake, so I'll type it in. 3 times 180 over 5, that's just 108. And that's in degrees. Now if you want to go the other way from degrees to radians, you have to use the fractions and cancel units. But nevertheless, 180 degrees equals pi radians. What is the measure of each interior angle of a regular 14-gon? Alright, so 14-gon is 14 sides. So n equals 14. Alright, we want each interior angle. And we know that the sum of the interior angles is n minus 2 times 180. But if we want each one, we have to divide by the number of sides. The number of sides is the same as the number of angles, so that's why we're dividing by n. Anyhow, n is 14, so 14 minus 2 times 180 and divided by 14. 14 minus 2 is just 12, so I'll do 12 times 180 divided by 14. And rounding off to 1 decimal, I get 154.3. And that's in degrees. So here are some circle formulas I'll give you on the test. Alright, in the diagram below, what is the value of x? So on this one here, we basically have a tangent and a secant. So it's going to be this tangent times itself. So that's 10 times 10, or 10 squared. And that's going to equal the exterior secant, which is x, times the whole thing, this entire segment. So this entire segment right here is going to be x plus 15. Alright, I basically added the 15 and the x. So it's x times the entire segment, x plus 15. Alright, 10 squared is 100. And distributing, x times x, and x times 15 is 15x. Alright, we have a quadratic. We have to set it equal to 0, whether we use factoring or the formula. So we need this at 0. The opposite of positive 100 is negative 100. I'll do that to both sides. Cancels here, and this equals 0. So I'll just put equals 0 right here. Now we can factor or use quadratic formula. Okay, I'm going to try factoring. So we need two numbers that multiply to negative 100 and add to 15. So I'm going to write out the factors for negative 100. We have 10 and negative 10. That adds to 0. Okay, let's see. What if I double this and take half of this? So double the 10 and take half of negative 10. 20 plus negative 5 is positive 15. So that's it. 20 and negative 5. So I'm going to rewrite this as two binomials. So since we have x squared, we're going to start with x and x and use positive 20 and negative 5. And now we're in business. Anything times 0 equals 0. So either one of these can equal 0. Okay, x plus 20 equals 0. And x minus 5 also equals 0. If you do minus 20 on both sides, x is negative 20. If you do plus 5 on both sides, x is positive 5. Now, if you look at the diagram, x is a length. It's the length of that segment. Okay, so we can't use the negative 20 because a length cannot be negative. So the only answer is x equals 5. Alright, the one on the exam, I will probably give you one that you factor, so you don't have to use quadratic formula. What is the standard equation of a circle with center at negative 3, 2, and 1 point on the circle, 5, negative 2? Alright, so basically, we need the radius. So we might as well start with our circle equation. Alright, that's going to be x minus h squared plus y minus k squared equals r squared. Now, the letters for the coordinates of the center are represented with an h and a k. And if you take a point that's on the graph or on the circle, that's going to be an x and a y. So what we have to do in order to solve for r is plug these in. Alright, so h and k and x and y, we have to plug them in. So let's see. X is going to be positive 5 minus h, which is negative 3. So it's minus negative 3. Alright, watch your signs. And that's squared. Y is negative 2. And that's minus k. K is positive 2. And that's squared. And it equals r squared. Two negatives make it positive. 5 plus 3 is 8. And that's squared. Negative 2 minus 2 is negative 4. and that's squared. It equals r squared. Okay, we have 64 plus 16. That's going to be an 80. And that equals r squared. Now, when you write the equation, you need to plug in r squared. We don't need r because the equation has r squared. You want to plug in r squared and also the center, h and k. Alright, so rewriting this equation here, I'm running out of room, but I'll do it right on the top. I'll do it right on the top here. So we have x minus h, which is negative 3. So minus negative 3 is plus 3. And we have y minus k, which is 2. And that's squared. And we said r squared equals 80. So r squared is going to be 80. Alright, I made a little bit of a mess. But this right here is the final answer. So if you're given the center and a point, you want to plug them into the circle equation, solve for r squared, and then you plug in r squared in the center in the original equation, and that's your final circle equation in standard form. Given that the area of the figure below is 350, what is the value of x? Alright, so this right here, I can see it's a trapezoid because this side is parallel to this side, but these sides are not. One pair of parallel sides is a trapezoid. And the formula for the area of the trapezoid, it's the average of the two bases. So 1/2 b1 plus b2 times the height. You can also write it as b1 plus b2 divided by 2 times the height. Anyhow, let me rewrite here. The area is going to be 1/2 b1 plus b2 times h. Now, it's given that the area is 350, so we need to plug that in and work backwards. All right, the area is 350, and that equals 1/2. The bases are the parallel sides. So this side is parallel to this side. I'll let this side equal b1, and I'll let the other side equal b2. Okay, so b1 plus b2 is going to be x plus 12. And that's times the height. The height is the distance between the two bases. It has to be perpendicular. So this right here is the height. That's 18. Now, we can certainly distribute, but the easiest way to get rid of 1/2 is to multiply by 2. Okay, times 1/2 is the same as dividing by 2. The opposite of dividing by 2 is multiplying by 2. So these are all multiplied. I'm going to take this whole thing and do times 2. And the 350 is also going to be times 2. Alright, 2 times 350 is 700. And like I said, these are all multiplied. So the order you multiply doesn't matter. So you don't have to distribute. You just take the 2 and multiply it by any of these terms. So 2 times 1/2 cancels. That's the most convenient. And we're left with this right here. Now 18 times x plus 12, we do have to distribute. So first I'll do 18 times 12. And I get 216. And then I'll do 18 times x, and that's just 18x. Okay, solving for x, we need the 216 on the left. Opposite of positive 216 is negative 216. Cancels here. And 700 minus 216, that's going to be 484. And bring down the equals, and that equals 18x. Alright, x times 18, the opposite of times 18, is divided by 18. I do that to both sides. And 484 divided by 18, I get 26.9 if I round off. So x equals 26.9. Alright, given two regular hexagons, the larger one has a side length of 11 and an area of 410. The smaller one has a side length of 8. What is the area of the smaller hexagon? Alright, so we have the side lengths. One of the side lengths is 11 and the other side length is 8. And we have one area and we don't know the other area. Okay, so the area is 410. I meant to put that in here. But anyhow, if you want to find the ratio of the areas, what you do is you take the ratio of the sides and square it. Alright, so I am going to put the larger side length on top. And I'll put the smaller one in the denominator or the bottom. Alright, so the large side is 11. Okay, they're all going to be, all side lengths are 11 because it's a regular hexagon. So the large side is 11 and the small side is 8. Okay, this is the ratio of the sides. But if we want the ratio of the areas, we have to take that and square it. So I'm going to take this right here and square it. When you square a fraction, you have to square the top and the bottom individually. 11 squared over 8 squared. So that's going to be 121 over 64. Okay, that's the ratio of the areas. And now we can set that up. One fraction is going to be the ratio, and the other fraction is going to be the actual areas. Alright, so this here is the ratio, and this one here is the actual areas. Alright, so let's see. We said the ratio was 121 over 64. So the ratio is 121 over 64. Notice I am keeping the large one in the numerator and the small one in the denominator. Now, for the actual area, I guess I should write actual area. It was given that the larger one is 410. Alright, it was in the write-up in the problem. The area is 410. So, the larger area goes in the numerator right here. That's 410. The smaller one we don't know, so we'll just call it x. And now we're in business. We can cross multiply. Top times bottom is 121 times x. Bottom times top is 64 times 410. Alright, the opposite of times 121 is divided by 121. Cancels here. And I'll do this on the calculator. 64 times 410 divided by 121. And rounding to one decimal, 216.9. And whatever units this area has, the units will be the same for the other area, but I didn't have any units there, so That's it. The circle below has a circumference of 18 and an arc length of 5. What is the measure of the central angle of the arc in degrees? All right, we can set up a ratio and proportion. So in both cases, we will do the part in the numerator, and we will do the whole thing in the denominator. Okay, the more this angle opens up, the more longer the arc length is going to be. So the ratio of the angles is the same as the ratio of the arc lengths. So let's see. This fraction here will be the arc length. Okay. And this fraction here will be the angles. You can say central angle if you like. Alright, so the part of the central angle we don't know, that's theta. And we're looking for degrees here, so the whole circle in degrees all the way around the circle, that's 360. Now for arc length, the part is just this part right here, that's 5. And the whole circle all the way around, that's the circumference, that's 18. It was given in the problem. Alright, now we're in business. You could just multiply both sides by 360, or you can cross multiply if you like. Theta times 18 is going to equal 360 times 5. Alright, the opposite of times 18 is divided by 18. Cancels here. And let's see. 36 divided by 18 is 2, so this is going to be 360 divided by 18 is 20. 20 times 5 is 100. So that's it. And they said degrees, so I guess that'd be 100 degrees. Alright, what is the volume of the composite figure? It's a hemisphere plus a cylinder. So we have the cylinder formula and the sphere formula. Alright, so this is a cylinder, this is a hemisphere, and this here, going from the center of the circle to the circle itself, that's a radius. So that equals r. And this right here is the same length. So that is also the radius for the hemisphere, 7.2. Alright, and this right here, this distance from here to here, that's 15. And that is the height for the cylinder. So this right here, the 15, is the height. So we have to add the hemisphere of the cylinder. Alright, so the total volume is going to be the hemisphere. So it's going to be half of a sphere. Alright, half the volume of the sphere plus the volume of the cylinder. Alright, so we have 1/2, and the volume of the sphere is 4/3 pi r cubed. So that's 1/2 times 4/3 pi r cubed. And the cylinder is pi r squared h. Okay, so we can get this fraction out of the way. 4 divided by 2 cancels, that's just 2. And 1 times 2 in the numerator. And this is just 1, so 1 times 3 in the denominator is just 3. Okay, so that's 2/3, and that's times pi. That's times r cubed, so that's 7.2 to the 3rd power. Plus pi. And now we just have r squared. So that's 7.2 squared times the height of the cylinder we said was 15. Alright, now you can do this all in one shot if you're good, but if you want to play it safe, what I'm going to do, these are all numerators except for the 3. So what I'm going to do is 2 times pi times 7.2 to the third. Hit equals, and then divide by 3. Hit equals. Now you take that answer and do plus pi times 7.2 squared times 15. And if I did it to one decimal, I get 3,224.6. Alright, whatever the units would be, they would be to the third power because it's a volume. Alright, what is the volume of the cone? We need to use 1/3 pi r squared h. So you can see here, they gave us the slant height, but we need this height right here. This is h, because the height runs from the vertex and it has to be perpendicular to the circular base. So we need to apply Pythagorean theorem in order to find the height. Alright, a squared plus b squared equals c squared. Going across from your right angle is always going to be c. The other two sides are a and b. Doesn't matter which is which. So a squared is going to be the height squared. B squared is going to be 5 squared. And c squared is going to be 9 squared. Okay. You can subtract 5 squared or multiply it through. Alright, so 5 times 5 is 25 and 9 times 9 is 81. The opposite of plus 25 is minus 25. Cancels here and bring down your h squared. 81 minus 25, that's 61, that's 56. Alright, so the opposite of squaring something is to take the square root. So I'm going to leave that as is for now. H is just radical 56. You can round off, but it's more accurate if you wait till the end. Now if you look at the cone, this is the center of the circle, and going to the circle itself, this is the radius right here. That's 5. So using the formula, we have 1/3 times pi times r squared, so that's going to be 5 squared. And the height h is radical 56. Now these are all numerators with the exception of the 3. So I'm just going to divide by 3 at the end. Alright, so I'm going to do pi times 5 squared and then times radical 56. Hit equals, and then divide by 3 at the end. And rounding off, I get 195.9. Okay, there's no units, but if there were, it's a volume. The units would be to the third power. What is the area of the regular polygon? Use special right triangles. The hint is that each interior angle is 120 degrees. Alright, so it's a regular polygon. All the angles are going to equal 120. So we could have found that if it wasn't given, but I wanted to make it shorter. And when you draw in the radius like that, that bisects each angle. So the angles here, the interior angle is bisected. That's going to be 60 and 60. Alright, now on the formula, we need the apothem and the perimeter for the area. So I am going to draw in the apothem. like so. I'll just draw it to the center of one of the sides. Okay, the apothem makes a right angle with the side. Now, if this is 60 degrees and this is 90, this has to be 30. So we need to use special right triangles. The formula was given in a previous problem, but across from 30 is going to be your short side, and across from 60 is going to be your long side, and across from the right angle is always your hypotenuse. Alright, so I'm going to go for the short side first because we need that anyway. Alright, so one of the formulas, we have the hypotenuse, so we have to use the formula with hypotenuse first. So for 30, 60, 90, the hypotenuse equals short times 2. We see the hypotenuse is 10, and that equals short times 2. So the opposite of times 2 is divided by 2, and 10 over 2 is just 5. So the short side is 5. Now, if we want to find the long side, that's our apothem. So I'm going to set it equal to A. And I'll do it in a different color. The long side is the short times radical 3. Okay, the long side is the apothem. The short side is 5, and that's times radical 3. So now we're in business. We have our apothem. The only thing is this side here is only half of a side. So if half the side is 5, the whole side length is just going to be 5 times 2, which is 10. Alright, so each side length is 10. So now we're in business. For the area of a regular polygon, that's just 1/2 apothem times perimeter. So that's going to be 1/2. The apothem is 5 radical 3. And for the perimeter, each side is 10. And we have a hexagon. Okay, so each side is 10, and we have a hexagon, so n equals 6. 6 sides, right? So the perimeter, if each side is 10 and there's 6 sides, it's going to be 6 times 10. Alright, so you can write 6 times 10, or you can write 60. And now, again, these are all numerators except for the 2. So I'll divide by 2 at the end. I'll do 5 radical 3, or you can even do 5 times radical 3. Same thing. Times 6 times 10. Okay, hit equals, and then divide by 2 at the end. I get 259.8. And the units would be squared if we had units, because it's an area. Alright, last one. What is the surface area of the triangular prism? Now you can add up all the faces if you want, but the shortcut is to use the formula for the surface area of the prism. It's 2b plus ph. Okay, capital B is the area of the base, and the base is a triangle because it's a triangular prism. So the base is basically the area of a triangle, which is 1/2 base times height. Now I don't want you to get confused with this height, so I'm going to write a T by the H, so we know that's the height of the triangle. So S is going to be 2 times B, or 2 times 1/2 base times height. And that height is the height of the triangle. And that's plus pH. P is perimeter, and H is the height of the prism. So 2 different heights. 2 times a half cancels. And the base and the height for a right triangle is just going to be the legs, okay, the sides that are not the hypotenuse. So the base and the height are basically 6 and 8. Alright, so it's just going to be 6 times 8 or 8 times 6. Plus perimeter of the base. It's going to be 6 plus 8 plus 10. When we say perimeter, we're looking at the perimeter of one of the bases. And we know the base is a triangle because it's a triangular prism. We could see the 2 triangles. So the perimeter is 6 plus 8 plus 10. Okay, and the height of the prism is the distance between the 2 bases. So that's 14. Alright, so now we're in business. And let me see, 6 times 8 is 48. And we have 18 plus 6, that's 24. Times 14. And real quick, 48 plus 24 times 14. And I get 384. And whatever the units were, they would be squared because it is an area.